Hello everyone, welcome to Digital Communication Tutorials. In this video, I am going to take up two numericals on raised cosine spectrum. Let me read out the first question here. A computer outputs binary data at the rate of 50 kilobits per second that is transmitted using a baseband binary PAM system which is designed to have a raised cosine pulse spectrum. Find the transmission bandwidth required for each of the following roll-off factors. First case is alpha equal to 0.2, second case alpha equal to 0.4, third case alpha equal to 0.8 and lastly alpha equal to 1. Right. Let us start with the solution part. The equation that relates the transmission bandwidth, the bandwidth of the raised cosine pulse spectrum and the roll-off factor is given by B equal to B naught into 1 plus alpha, where B is the transmission bandwidth, B naught is the bandwidth of the raised cosine pulse spectrum, and lastly alpha is the roll-off factor. If I come back to the numerical, I will see that the value of the data rate, which is RB, is given as 50 kilobits per second. So, let us now substitute that into the equation for the bandwidth here, which I will call it as equation 1. So, B is equals to B naught into 1 plus alpha, but we know that the bandwidth B naught of the raised cosine pulse is equal to 1 divided by 2 times TB. Therefore, I can rewrite this as B is equals to 1 divided by 2 TB into 1 plus alpha. We know that 1 divided by TB is equal to RB. Therefore, I will rewrite the equation for the transmission bandwidth as RB divided by 2 into 1 plus alpha. In the numerical, we are told the value of RB is equal to 50 kilobits per second. Therefore, it is equals to 50 into 10 power 3 multiplied by 1 plus alpha divided by 2. This is the expression for the transmission bandwidth, and let me call this as equation 2. Now, since we are asked to find the value of the transmission bandwidth for different values of alpha, I am going to create a small table here. In the first column of the table, I will have the alpha itself, and in the second column, I will have the bandwidth, particularly the transmission bandwidth in terms of kilohertz. I will write the different values of alpha. We are asked to find the value of B. They are 0.2, 0.4, 0.8 and 1. And for these values, let us find the value of the transmission bandwidth B. Now, if I substitute the value of alpha as 0.2 into equation 2, the RHS of equation 2 reduces to 30 into 10 power 3. Therefore, the transmission bandwidth for alpha equals to 0.2 is 30 kilohertz. I will just write 30 here because the column already represents the bandwidth in kilohertz. Then, if I substitute alpha as 0.4, I would get this as 35. For alpha equal to 0.8, it is 45. And lastly, for alpha equal to 1, it is 50, all in terms of kilohertz. Right. So, that is the answer for this part of the numerical, which is to find the value of the transmission bandwidth B for the different values of alpha given in the numerical. Let me now move on to the second numerical in the sequence, and I will read it out here. A binary PAM wave is required to be transmitted over a pair of copper wires, which are actually low pass channels, with an absolute bandwidth of 75 kilohertz. The bit duration is equal to 10 microseconds. Find a raised cosine pulse spectrum that satisfies these requirements. Let us start with the solution part. We are told we have a absolute bandwidth of 75 kilohertz, which is represented by B, and this is 75 into 10 power 3 hertz. And the value of the bit duration, which is represented by TB, this is given as 10 microseconds. So, it is 10 into 10 power of minus 6 seconds. If you look at the last sentence, you will note that we are asked to find the raised cosine pulse spectrum value. In simple words, we are asked to find the value of alpha which will satisfy these conditions. So, let us start by once again writing an equation that relates the absolute bandwidth or the transmission bandwidth B, the bandwidth B naught of the raised cosine pulse spectrum, and the roll off factor alpha, which is given by B is equal to B naught into 1 plus alpha. The value of B is 75 kilohertz. So, I will write it as 75 into 10 power 3 equal to B naught is not given, but we know that B naught is equal to 1 divided by 2 TB, and I will use this to rewrite B naught as 1 divided by 2 multiplied by TB into 1 plus alpha. So, this reduces to 1 divided by 2 multiplied by 10 into 10 power of minus 6 into 1 plus alpha. I will rewrite this equation for alpha now. So, 1 plus alpha is equal to 75 into 10 power 3 multiplied by 2 into 10 into 10 power of minus 6. So, alpha is equals to 75 into 2 into 10 multiplied by 10 power of minus 3 minus 1. After computing, you will find this to be equal to 0.5. This is the answer for the roll-off factor of the raised cosine pulse spectrum, which satisfies the transmission bandwidth of 75 kilohertz and a bit duration of 10 microseconds. Right. With that, we have come to the end of this video. If you like this video, kindly like and share this video and subscribe to my channel for more information on digital communication. Thank you for watching. Have a good day.